Check, check, check. 1, 2.
Did you hit the button?
I did, I think. Should I try it again? Hello?
He's going to menu over there.
Okay.
He'll bring you up when you're ready.
Okay.
Hello, everyone. Okay, our next talk is going to be about scaling, and this is Brock Whitten.
Hello. Thank you. Can you guys hear me okay? Okay, there we go. All right. So all these mics going on and stuff. Really enjoyed that last talk, mainly because it reminded me that I'm going to die soon, and not in not that there's anything, I don't have cancer or anything like that, just that relatively speaking, we're all going to die soon. And and we need to, get our shit together and, use our time wisely, right? So I thought that was really great. Okay, so yeah, the intro was scaling, but that's super loaded term. It's really, I'm going to mainly talk about writing scalable systems, or even starting a project and making it in such a way that it can scale. But controlling complexity is the essence of computer programming. This is something that I think that oh crap, that's probably going to happen a lot. It's something that we often forget, that as engineers, our job is to build stuff that that is properly controlling complexity and fighting complexity. And it's not just about getting stuff to work. And sometimes we just get things to work and we're like, okay, we're done, we're good, let's ship it. But really, there's more to it than that. We need to remind ourselves about that. So my name is Brock Whitten, and I go by Syntaxy on GitHub and Twitter. And most people know me from my involvement on PhoneGap. That's been a while ago now that I've been involved in that. But mainly the last few years, I've been working mostly in cloud computing infrastructure, mainly at Joyent, and now with my most recent project, which is a hard platform built on Dropbox. Big API guy, really had a long stint with REST and building HTTP APIs, and I like that. But there's a lot of things that I've learned recently that have kind of made me rethink some of my approaches and paradigms, and that's kind of what this talk is about. Is the last 9 months I've really kind of discovered some new patterns and questioned some of my approaches that I've done in the past. So my company's called Chloe, and I started this with Rob Ellis, who I worked on PhoneGap with, and scalable systems. So this talk isn't about scaling, it's about building scalable systems, and with minimum complexity, and that is the key. And really, scalable systems isn't really something that you build. Scalable systems is something that you get. It is a byproduct of designing things correctly. So what is complexity? Well, complexity in software can be defined 3 different ways. One would be what is the mental overhead for a developer to look at a code base and grok it, understand it, commit back to it. The other would be what is it take for the user to use a project. That doesn't necessarily mean end user, that just means any system. What does it take, and how much of the inner workings are you bubbling up to the user and exposing? So the third way, well, the first two are always kind of combating each other. As you make things easier to use, you're increasing the overhead or the complexity of your system, and vice versa. But there's a third method which kind of addresses the first two, and it's counterintuitive, or at least I thought so, but it's kind of beautifully simple. And the best measure of complexity is actually lines of code. And don't confuse that with the best measure of productivity. And I'm sure we've all reminded managers or other people that yeah, you don't measure productivity by lines of code. But it actually is, oddly enough, a very good metric for for measuring the complexity of a project. And this is for two main reasons. One is that it forces us to create these interfaces, these clean interfaces, and address the user problem at the same time as addressing the mental complexity problem. So I would love to get into this further and why that this is the case, but just spoke on that. So what is the sweet spot? So it is, this could be a talk on its own, but let's just, for the sake of what I want to talk about, let's assume this is truth. But that says 200 to 400 lines of logical C code. And I don't know how that would translate to JavaScript. I tend to think that it's more around like 200 lines of JavaScript. But anyway, let's move on. But you're probably thinking like, OK, so what you're saying to me is I could build a system that's like millions of lines of code as long as I break it up into like, thousands of NPM modules that are all 200 lines of code. And the answer is, yeah, that's exactly right. It's really the only way. There are two ways of constructing software. One is to make it so simple that there's no obvious deficiencies. The other is to make it so complex that there's no obvious deficiencies. The first method is far more difficult. It's really easy to build a system that has no obvious deficiencies if you make it big enough. So what is a scalable system? Most of us feel like our natural intuition is, oh, a scalable system is like, yeah, like 20,000 requests per second, right? Or 30. Well, really, that isn't important. Like, what's important is a scalable system is something that can adapt, that you can take the bottlenecks and you can replace them with something that works better, that you can replace a part without breaking the whole. That is a scalable system. And you don't need to be a big enterprise to build scalable systems. You should be thinking this way right from the beginning. So agility, replaceability is the key. So I think like for me, the goal is like, let's get it in terms of performance. Like a good way to think about it is like, let's get it so that the bottleneck is the reverse proxy and the message broker. And if that's where your bottleneck is, like, yeah, this architecture is going to work great until like the load is too big for our reverse proxy, then you've probably done something right. So as you can tell, this talk title, the title for this talk could be something along this line. Brog wins tips, tricks, and learns lessons for creating scalable systems by building small replaceable libraries put together by clean interfaces using Node.js with arbitrary opinions thrown in here and there. So this is the project I'm working on now. This is called HARP. It's the HARP platform. And it is, like I mentioned, it's developing within Dropbox. So it's zero configuration publishing. I tend to think that we're using far too complex tools for most of our tasks. And so I'm building something that I feel is going to address that issue. And it's not going to be the be-all, end-all, but I see us, and I do this all the time in my own work, is I'm like building a blog or maintaining a documentation website, and I've got Node and NPM and like all these modules, and I'm like using Jade and Bootstrap with less, and I'm like, this is crazy. And like it's great when you get it all set up, but you got to really know what you're doing to set this up, and you have to maintain that environment moving forward, and that kind of sucks. And it just because like when you're going to go solve a hard problem, like yeah, innovate, get really creative with the tools that you're using, and do it. But the other stuff like documentation and guides and all that, like let's make this really easy. So that's the goal there. I actually didn't mean to talk much about that, sorry. Okay, so there's two things that I think like right out of the gate you want to address. What part of our system needs to be centralized? What needs to be distributed? Getting this wrong really, really sucks. Make sure that you get this right. And it's not that hard to figure out. So the first one, I'm going to talk about the first one, which is centralizing something. And this is kind of a lesson I learned, is that you probably can't see that very well. It says REST is for humans, and it sometimes isn't the best fit. Don't build REST APIs and then build a whole bunch of SDKs on top of that. And like, build a good REST API as an endpoint of like, hey, if someone, like REST is great because it's like, anyone can understand this. If you're writing Scala, or you're writing Lua, or you're writing Ruby, or like, it doesn't matter. Here's an interface anyone can talk to. And that's the point there. But sometimes it's not quite right. And I have an example. So the first thing that we built was this system. It's like, okay, I've seen it enough times where companies have like, oh, all these multiple accounts, and it's like at one time you have to merge this. Like even Google's done this, like 37 Signals, so many people have made this mistake. It's crazy. And I don't know why people are still doing it. If you have customers, have that in a separate system. Like these like devise tools where you put your customer data in your application, that is crazy. Don't do it. Even if you're building like a weekend hack project, like have the customer data in a separate system. So here are our requirements. We need something that's centralized. It's simple, it's easy to use, it's easy to integrate into production, and well, it needs to be fast for reads. But this is the interface that I want. So I want to be able to require this module, connect somewhere, which is right there, and I just want to be able to do this stuff. I want to be able to create accounts, get validations back if it's not good. I want to be able to send a customer an email. And I don't want to have to set up email on every application that I send. I want to be able to do it from any system, from any script, without setting up anything. And I would like this to be able to listen on a port and serve another slave. Sorry. So all that I think is, there's a red arrow there in case you can't see it. So the configuration change is right there, and I should be able to run this locally or connect remotely to something. And this is what the config would look like for a master. I might have like, some postmark information for doing that, and whatever I'm storing the data in, which in our case we use Redis, and set up some auth. And then if I'm connecting to something remote, it's a slave, and there's how I connect to the remote. But what's nice about this is my API does not change. I don't change one line of code in my application, and I can have as many clients as I want connecting. So it looks something like this. I have a master, it's talking to Redis. I have some slaves talking to that. And the slaves can even listen on a port and serve up a request. And there's auth at any layer. So if I want to if someone wants to have access, or I want to give someone access to customer database, I could set up a read-only with different credentials and all that. It's really simple, and then I can take it down when I'm done. So how is this done? So I open this by like saying don't use REST, but this is why. It's really easy to serialize the arguments of JavaScript and pass it over the wire over HTTP. And HTTP is like a great transport layer for this tool, but to try to get this to work with REST is very awkward, and it's not going to be as reliable, I don't think. So a few other opinions on REST. Stop writing SDKs, I mentioned that. Pretty print your JSON, and put a carriage return at the end. Make it really good for the human to interface with. And that's what's going to make people will make great clients if it's easy to use. And make great docs. And there's no shortcut for that. Really care about it. Do handwritten docs. And curl is the litmus test for a good API. So, how are we doing for time?
Doing awesome.
Yeah? Okay.
Yeah. Keep going, Brock.
Okay, so you're probably like, cool story, bro. Like, centralized system. That's not really scaling. No big deal, right? Okay, so let's talk about distributing work. So the key for this is messaging. I'm really thirsty. Seattle knows how to make a good cocktail, huh? I'm feeling a little fuzzy. Okay, so let's move on. So I would say like everyone in this room should understand messaging patterns. If you're building web applications today, a great place to start is go to 0MQ and read the guide, and it's going to take about like 6 or 7 hours to read that thing. It's worth a day's losing day of productivity to read that thing front to back. But I'm going to give you the 2-minute version. I'll try to talk about a few patterns. But when you understand these patterns well, you can solve really complex problems with incredibly simple solutions. The first pattern is push-pull. And this is probably what most people think of messaging, is something like this, where we have all these jobs and we want to distribute this to workers. And to set up another worker, it just adds it. It just discovers and adds jobs to that worker. So that was a fan out, but you can also do fan in. So all these guys are pushing to one centralized location. Then there's request reply. This is a lot like HTTP, where I send a request and I wait for the response. And pub sub, which is every message. So this doesn't round robin. This actually sends every message to potentially every subscriber. But there's this problem that everyone should be aware of, which is discovery. Sorry, I think I'm pretending to talk into this mic, but actually I have a lapel, and it's kind of tripping me out. Okay, so the discovery problem looks something like this. So I have push-pull, and it's great. I can spawn some new workers, which is awesome. But what if I want another client to be distributing jobs? Okay, well, what happens here? Now I have these workers that need to, these all connected to this. So this binds to a port, and these connect to that, and they're getting messages. It's sweet. But now we want another thing to distribute workers. So what you would have to do here is you'd have to have the workers be restarted, being aware of two different clients, and you would have to do that one at a time. But this isn't good. You want workers. You want to be able to spin up workers without them having. You want them to be dumb, right? So there's this paradigm, which is just pairing these two. The pull and the push are actually separate, and that is for discovery. So that what you have in your message broker is basically these two processes, and then you can bring up new clients or you can bring up new workers. The workers know where to go to get jobs, and the clients know where to go to dispatch jobs, but they are completely unaware of each other. And the same goes for pub sub. It's worth mentioning that this is commonly known as X pub, X sub. That's what 0MQ calls it. Okay. So how do you do this? Well, I'm going to show you a little bit of Axon, which is a project by TJ from Express and Jade fame, and a whole bunch of other great stuff. And by the way, if you haven't explored Substack's modules, go spend a week, and it's crazy. Once you start playing with that stuff, it's oh, this is he's solved problems that you've only thought about, and you realize that someone's actually taking those ideas to their logical conclusion, which is kind of fascinating, but it's pretty trippy. Anyway, so this is how you would set up with Axon. This is the self-discovery pairing of two message brokers, And yeah, it's pretty simple, isn't it? So we're binding to two different ports. One of them is listening for messages, and it's sending out. So you still need clients to publish messages in, and you still need workers to do the job. But here you have a message broker. It's like 12 lines of code. So you have what I just showed you was, I think, on the left, and on the right, this actually isn't quite accurate, and it's crooked. But this would be a request reply paradigm, same thing. I don't actually have a diagram for that, sorry. So I'm going to, how are we for time?
You're good.
Okay, I'm going to show you something. I'm going to show you this working. So we have this paradigm in the Heart platform where, okay, we have these clients, and this could be an API or it could be a web client, and we want to publish jobs. So someone wants to do a deployment, so we reach into your Dropbox and we do a bunch of stuff, but we do this with workers. But we don't want this to be blind. So to us, the right idea is that you can send a job off. It's gonna do its job. It'll take like any amount of time, and we're gonna get live updates, progress bar, all that beautiful stuff. And if you disconnect, close your browser, your job's still gonna finish, all that good stuff. So the way to do this is a few different things. Like, it's not just a simple fan out, right? So we have a push-pull, and so the client sends a job out to the workers, and one of the workers picks it up. Then the worker goes, okay, I'm gonna do a request reply to the server, because this is very quick. I'm gonna tell them to update the data store or the database, saying that I'm working on this. So once that's finished, it's coming back. So now we have two different pipes. We got push-pull, and now we have a request reply. Now I want to send updates to the client on how it's going. So when the client sends a message in to get done, it's then going to connect to a socket to a pub sub. So the client connects to this pub sub, and the worker is unaware of who the client is, but it's like, I'm going to publish to this channel all the work that I'm doing. So it publishes to the channel. Once it's finished, it does another request reply, updates the state. Everything is beautiful. To scale out more clients, you could just spin them up, or if you need to do more workers, you can do that as well. So I'm going to kind of demo this a little bit. So here is our message broker up in the top left corner. And if I have this up, that's not it. Here it is. So we have basically a few different things. So we have a X push, X pull, and that's basically the slide that I showed you a moment ago. We have another component, which is request reply. We have pub sub, and we have the pub emitter and sub emitter. I didn't talk about that, but it's pub sub, but with channels. And we'll boot this up in the top corner. And we need clients. So clients are going to send some jobs out. There's one. Each dot represents a job, and there's nothing picking it up. So we better get something running. So we're going to spin up a worker. And that worker actually picked up all those jobs because it sat in a queue. And everything's great, right? We got clients going out. We got workers, a worker doing a job. This is great, but you know, things heat up, and we get more jobs, right? So that worker's working pretty hard, so we're going to spin up more workers. All right, this isn't bad. They're still working pretty hard. Let's get a couple more of these up. All right, so not every worker's doing pretty good. Seems healthy. So this is awesome. But what about that progress bar, right? So let's subscribe to this. And all of these workers are actually publishing their progress to this subscription. And this is sweet. Do you guys like this? This is cool? Yeah. I want to see queue size. Queue size? Yeah, that's funny because like this came up last night about like watching the queue, and I'm kind of the opinion that you shouldn't really watch queues. Like, sorry? For a demo, it's fun. Yeah, it's true. But I say like observe your workers, and that's your insight to how the health of your system is, because your queue is going to back up only if like your workers aren't healthy. So that's just a side note. So one more thing, we didn't get the request reply. I actually don't have this spamming the clients yet, but these workers can actually do request reply to update state, and this just represents that. And a little R pops up anytime a client fulfills that request. All of these are going through the message broker. That deserves to be mentioned. I should have had some sort of output showing stuff happening there. But anyway, that is kind of like how you do that stuff. So that's what I have for you. Thank you.